welcome to my talk about what the heck is WebAppSec. So it's an introduction into what web application security is, and I'll give you a few insights to actual vulnerabilities. Here's the link to the slides or the QR code. Wait, let me check. Why is this? Okay, now it's full screen. Maybe this would be put up somewhere on the conference website as well. I'm not sure. I'll leave it up in the end again so you can check. So really, web application security in 30 minutes? I guess not, but I'll try to give you a few basic insights into what also the specifics about security in web applications are, show you two common vulnerabilities, not really in action. I have a demo video, but we don't have time to do that live now, and give you a few stats and context and key takeaways. Who am I? Well, Andrea Klaura is my legal name. That's how you can find me on the webs. But in real life, I'm actually just Jackie. My neural net is trained on Jackie, but I like my other names too. Feel free to use them. But then I'll take some time to react. Yeah, I use in binary gender space in which we are operating most of the time, I'm using just classical female pronouns. But if you want to explore the wider gender multiverse, feel free to use sie here. But what do I actually do? It was already said, I'm mostly an open source engineer doing backend applications with Python and Django and a bit of DevOpsy stuff. But I also constantly try to clone myself to do other things, also already announced, teaching and other stuff, community stuff. But also why am I teaching? Why I'm talking about security? There's no security in there. Well, I also have a security background, and I'm teaching at the University of Applied Science in Salzburg an ethical hacking course, where I teach students to actually hack web applications in order to find out how do these vulnerabilities work and how can we prevent that. So maybe when it comes to security, you've heard about these terms, white hat hacker, black hat hacker, maybe gray hat hacker. So the good, the bad, and the unsolicited security researcher. And you may wonder, which type of hacker am I? As you can see, I'm the too many hats hacker, or let's say rainbow hat hacker. If you want to find out more, just visit my webpage. But now let's jump into the security topics. I won't go through this XKCD comic. Some of you might already know it. I leave it to you to look it up later. But the important thing here is that security is not a technical issue. I mean, you could call using a $5 wrench to hit somebody until you get a password a technique, but actually security is a social-technical organizational matter. You need technical measures, but if you only try to solve security on a technical term, you are flawed from the start. Also, short disclaimer, what I'm presenting here is just a very boiled down version of what you could find in the slides or in the documents of the heck out of this website course, which I created for Melanie Hossiner for the Detect Women's IT Studies. And first, a bit about terminology. You have to touch that, but I'll gloss over it quickly. So what are the key goals in information security? It's called the CIA triad. Doesn't have anything to do with the agency. I mean, the agency also deals in information and security or insecurity, you never know. But in this case, CIA means confidentiality, which is the property of the system that people can only see what they are supposed to see. And integrity, which is the property that people can only manipulate what they are supposed to be able to manipulate. And availability, which means that information is available when you need it. That doesn't automatically mean 24/7 availability. In practice, it often does. But it means that if there's some information you need on Monday mornings, well, it's there on Monday mornings, every Monday morning. But maybe it's not there on Tuesday evenings, on Wednesday, or wherever, because you only need it then. That's important about availability. So how do we achieve it? In IT, usually through access control. So we have processes for identification. So like if you go to the library to lend out a book, you might show your ID card. Well, in web apps, you usually come with some username or an email. But then, okay, anybody could type in this username or use this email. So we also have authentication, making sure that the person who they claim they are actually this person. So maybe we use a password for that. I mean, by now we know that passwords are often shared unintentionally, but sometimes even intentionally. So passwords might not be the best measures. So this is why multi-factor authentication came in. And so we're using at least a second factor to make sure the person who claims to be this person is really this person. So once we have that, okay, fine. This is our user in our system. They are allowed to do certain things, but what are they actually allowed to do? Here, authorization comes in. So whatever the user wants to do, we have to check, are they really allowed to do that? Because different users might be allowed to do different things. And what do we need to keep looking out for when we implement all of that? Mostly vulnerabilities. And what is that? You might think about code now, but basic vulnerabilities are pieces in your technology, not necessarily code, which can be, let's say in a most generic way, can be used in a different way that it was intended, in a different and potentially harmful way. That's a vulnerability. It might be there. It might not be super bad that it is there in your system right now, but it's there. It becomes bad as soon as there is an exploit for it. And an exploit is just the active use of a vulnerability or more vulnerabilities. So the exploit is, for example, a script somebody wrote which can use or make use of a vulnerability to do something that was not allowed in the system before. And the most nefarious way of exploiting something or of an exploit is the zero-day exploit. So zero-day exploit means you have found something, you have maybe found a vulnerability, created an exploit that nobody else knows about. The important point to keep in mind here is, well, you found something that nobody else wrote about on their blogs or it's not in the vulnerability databases. It doesn't necessarily mean that nobody else found it. I mean, what would be the ethical thing to do if you find a zero-day? To disclose it, responsibly disclose it. You might think, maybe I want to use it because, I mean, this is valuable for whatever. No matter how, even if a state actor wants to use it for a legal prosecution, it's not a good idea to not disclose it, because just because you found it and you think nobody else found it, it will be guaranteed that somebody else will find it. And cyber criminals will do other things with that you might not want to happen. So where do vulnerabilities come from? First thing we think about, especially as developers, probably is faulty, buggy, or insecure code. But it's not just that. It's also faulty or insecure use of code. And we'll get to that in a minute. And I think most importantly, it could also be a faulty, insecure, or even missing systematic approach to software development. And the important point is also a systematic approach to software development that keeps security in mind from the start. If you don't have that, you can invest a lot of time in trying to make your code better, but the process is flawed and you will introduce some vulnerabilities, I guess. So how do they actually come about? And these are just a few examples. For example, already in the planning and design phase, or in Agile, we are doing it over and over, but you're not writing code, you're just planning and designing systems. And if you trust the user, or even if the user actually is trustworthy, but you trust the user's browser, which might be compromised, then you probably will have a problem at some point. Or if you use outdated or self-coded encryption algorithms or insecure protocols. I mean, who would do that, writing your own encryption algorithm? I mean, you might say, the things out there, they are not really secure enough, aren't they? And I really know about encryption. But actually, you are creating a product. And you're not working as a cryptographer full-time. If you would be working as a cryptographer full-time, I mean, you would not create this application. So that's the whole point. Don't write your own encryption algorithms. Rely on proper cryptographic work that's out there in the open and open source. But then, of course, while coding, we could introduce a lot of vulnerabilities. First of all, if we use incomplete or missing input validation or output sensitization, or insecure methods and queries to access the database, and we'll see two examples later. But also, for example, if we pass user-provided content, like user-provided files without precautions. And that's the thing we often don't think about, that the user input is not just the thing the user enters into the form and then sends to the web server. User-provided input is also the configuration file some admin sets up when they set up our software on some server. And hard-coding credentials is an all-time favorite. But but also at runtime. You could leave debugging on in production. I mean, you could ask, why is it there in the first place? Maybe it was an insecure by default setting, and even if you have in the docs a big warning, hey, if you run this in production, turn off debug mode. Well, somebody will forget about it, so that's not a good default. But also there are some cases where really in production, for a very limited time, you need to turn on debugging mode under controlled circumstances. But then hopefully these circumstances are so controlled that you can make sure that it's also turned off again. But still, things happen. The most important thing, there's no 100%. I mean, there's no 100% in probably anything, but specifically in security, there's no 100%. If you think you can become 100% secure, you're flawed. You will be guaranteed to introduce some flaw because things change. And security is not a state you want to reach, but it's a process of actively increasing the chance to not getting hacked, basically. So when we, and this is valid for anything, for any app, for everything in security. Now, what is the specifics about web servers and web applications? First of all, we speak HTTP, which means when I want to visit a website, my web client requests from the web server some documents using HTTP, the Hypertext Transfer Protocol, which is a text-based and stateless protocol. And we'll see what it means in a minute. So HTTP should be used with TLS encryption anywhere. So use HTTPS. And this is a rule. Of course, there are exceptions from the rules. But if you make an exception from this rule, really know what you're doing. And we have to keep in mind that the browser does a lot of automatic stuff to display a website. And we'll see what that entails. So this is what an HTTP request looks like. I mean, yeah, I won't try to go through it, but it's a graphic from Wikipedia, and somebody just opened a telnet and typed in something. It's really text you can type in and you can read. And this was sent along the net through many, many routers, I guess. And whoever is on any of these routers might read it if it's not encrypted, and might not only find out about the web server, but also maybe about what the user posted. User credentials, for example. And also, the web server, if you do the next request from the same IP, from the same browser, the web server doesn't care. It just says, oh, another request. That's fine. That's the statelessness of HTTP. So how does the server actually know that we already logged in? The server doesn't. So that means around that. Coming to cookies. I mean, everybody likes cookies. But the thing with cookies is they are used for a lot of questionable stuff. Not always illegal. I mean, they are used for lots of legal, questionable stuff. If you go to a website, you get 100 cookies from 100 vendors. I would say this is questionable, but still legal, probably, hopefully. Also, cookies are used for illegal stuff. But the most important thing about cookies, they are used to work with the statelessness of HTTP. For example, to remember logged in users. How would it look like? The server might send something back after you entered your login details and the server confirmed this is actually you. They'll send something back and say, hey, here are some cookies, a session cookie, maybe some other cookies like that foo equals bar, chocolate equals good, raisins are evil, whatever, we don't care. But the important thing, there was a session token. I mean, maybe not this session token. Maybe a cryptographically strong session token, which cannot be guessed. But nevertheless, that's the server sending my browser something where the server expects whenever it gets that back in a subsequent request, this has to be the user. So when my browser makes subsequent requests to this specific website, well, it just will send all those cookies to the server. And I might not care if my raisins are stolen. They can steal my raisins. But if somebody steals my session token, that's not good. So what happens when I visit a website? And this is an excerpt from a talk you can go and watch on YouTube. If you really want to know why we need to make our communication secure already on an encryption level. But I just want to quickly go through that. So if I type in something in my browser, like let's say debian.it, this is my old server collective, and hit return, the browser first has to find out, hey, who serves debian.at? What is that? Well, it needs to get an IP address. So it asks some DNS server, hopefully a well-meaning, non-harmful DNS server. And this DNS server says, hey there, yeah, I have the IP address, so it's this here. And then the browser just sends some HTTP request packets to this IP address, where hopefully a web server is listening. And the web server then checks, debian.at, yeah, I have this website here. I have files for these websites, or maybe scripts. Of course, the web server might have a lot of other stuff too. But then the web server just responds maybe with the index page for this website. And it sends back some packets, one or more packets over the net, which route through many routers. And then my computer receives it, or my operating system, and assembles all the packages according to TCP/IP. And then my browser is handed the result. And then the browser has some HTML. It won't display the HTML because we don't want to look at that. It displays a nicely rendered website. So already here, you see there are a lot of parts involved where things could go wrong. But wait, is that all? Well, the browser got this HTML. In the HTML, it said, hey, to make it a bit more nice and appealing, there are a few images. So the browser loads all the images. It wouldn't ask us, hey, should I load those 5 images? Because we want to have a convenient browsing experience. So it does that for us automatically. So it makes more requests and loads the images from this server. Or maybe a different server, if the thing in the HTML said it's on a different server. And then it loads some CSS files to make the page visually appealing. And then it loads some JavaScript files to make the page interactive, nicely interactive. And all of that it does automatically. Please go ahead, try to browse the web for a week with JavaScript turned off. It's a horrible experience, unfortunately, but that's how it is. So it's not necessarily bad that the browser does that. It's what we expect. And it also does potentially lots of more automatic stuff. And this is just, we need to keep in mind, because in all these stages, things can go wrong. So websites versus web applications, that's just a short graphic. I'll leave that up to you to look into it later if you want. The important thing is the web server usually is not the problem. The web server serves out content. It might be static files, no problem there. The problem is with web applications, the web server just gets a request and says, I don't know what to do with that. I have to hand it to the actual application, to a PHP interpreter, to Python, to Ruby, to Java, whatever. And then some scripts are running, or some programs. And they are communicating maybe with a database, with other web applications, with APIs, whatever. And only then the web server returns it. So the web server itself is not the problem. The thing we produce, the web application, might be. So 2 common vulnerabilities. Maybe I could even slow down a bit. I think I'm good in time. It paid off to drink a coffee before the talk. Well, 2 common, quite old and simple actually, but still prevalent vulnerabilities. The first is cross-site scripting, which means tricking the web app to include JavaScript code into a HTML output. How would it look like? Imagine a normal greeting on a web page. So this is, if you don't know HTML, it's the paragraph tag. Here's the closing tag. Everything between there is styled as a paragraph. So it says, hello Mafalda, how are you? And Mafalda is styled in italics. So this is the username, we assume, which the user provided first through a web form. And the web application said, yeah, the user gave me the username, so let's insert it here, where the username should be showing up. So now imagine we have a user, Mafalda, who is creative, let's say, and they didn't just provide the username. They provided the username and a little bit more. Like they typed into the username field, Mafalda script alert evil script. And the web application said, well, that's a username, I have to render it here. And if I don't take any precautions, the browser gets it and says, well, I'll display this web page in a nice interactive way. And this is apparently a script, a JavaScript code, which makes the web page nicely interactive. So let's do that. And what does it do? An alert box will pop up and say evil, which in itself is not that evil. But if you can do that, you can do anything like steal cookies. And that would be evil. Another type of attack is an SQL injection. Basically, the cross-site scripting is also kind of injection because you inject JavaScript somewhere. And SQL injection is about injecting SQL code. So it's tricking the web server to include custom SQL code into the database query it will do anyway. How would that look like? Imagine, again, we query a user for the login, and they provide a username. Well, again, Mafalda, who's quite creative. And so the query would look like that. It says, select everything from users where ID equals Mafalda. So, but only where ID equals Mafalda, because we only want to return to this user their own data. We said Mafalda is creative and did not just type only their username. What they typed is Mafalda, quote, or 1 equals 1, semicolon, dash, dash. So if we introduce that into the query right here instead of Mafalda, we'll get select everything from users where ID equals Mafalda or 1 equals 1. And the dash dash is just a comment to get rid of the initial query, because otherwise the database would say, hey, there's an error. I mean, then we would still be fine if the database says an error. I mean, it's not nice for the user, but we would realize something's off. In this case, nothing's off, but what do we get back? Not only Mafalda's data, but every user's data, because 1 equals 1 is true in every case. That's a SQL injection. Again, this might not be that evil, but as soon as you can do that, you can do anything. You can read out the whole database, and there are even ways to use the database to execute system-level commands. So I leave also that for you to look up later. If you don't know Little Bobby tables yet, look it up. Now you know why it was a bit nefarious of this mom to name her boy Little Bobby tables. And in action, if you want to see that in action, actually, I've prepared this demo video. It's linked in the slides, and I'll show you how to also, if you have Docker installed, spin up quickly a damn vulnerable web application or the OWASP juice shop and actually try out some SQL injection, cross-site scripting yourself. Also, the DVWA is more instructional. It provides background infos and hints. While the OWASP Truth Shop is more really the training is ground. If you already know what you want to do, then spin up the OWASP Truth Shop and try out a bit. So hone your hacking skills. Now, to come to an end, so we actually have some time for questions. I'll give you a few context info, stats. Because you might want a SQL injection, cross-site scripting. Really, is this still a thing? Well, unfortunately, it is. The OWASP Top 10 is kind of an industry report about which vulnerabilities are out there. It comes out every few years. This year is not out yet, but in 2017, injection attacks were on place 1, XSS on place 7. In 2021, they took these two categories together. It's still placed on place 3. Maybe we get less of that this year, but I wouldn't hope for too much. It's still a thing. And just yesterday, I got mails from the Django security announcement lists, and there was a cross-site scripting attack in there, and that constantly happens. Also, to give a broadly used example, WordPress, the probably most widely used web application, blog, CMS, whatever you want to call it, and WordPress brings out a yearly security report. And in 2023, cross-site scripting were the most disclosed vulnerabilities. SQL injection was on place 4. In 2024, basically it looked the same. We just had more of that. And one thing important when it comes to WordPress, the core actually is rather quite secure. I mean, from time to time, like in every software, you will find a vulnerability. They will be quite quick to fix it. But most vulnerabilities come in WordPress from the community. So the community is a vulnerability, kind of, not always. So just when you use plugins, community-provided plugins, really make sure to look, okay, is it well maintained? Is it still maintained? And do updates regularly. But that's probably valid for anything. So now we can already come to the key takeaways. Key takeaways for developers. But as initially announced, we might not all be developers. So these are also key takeaways for devs and for everybody else who is somehow involved in software development and does not want their developers to inadvertently introduce, let's say, negative value propositions into the software. Keep that in mind. First of all, always validate user input. There are more obvious cases where we're doing that, but then, for example, the config file are less obvious places. Generally, always validate. And of course, a generic text field where they provide their CV, biography, whatever, you might just say, okay, they can write what they want. But still, think about it. What could I validate? What could I exclude? What could I filter? And if you really have to accept whatever they provide you, always, not only then, but always, make also sure to sanitize the output. So the things that end up in the final HTML, the things that the web server sends back, because the web server doesn't care. Your web application provides that. Also use prepared statements, or go for object relationship mappers. Don't do raw SQL queries. And there are circumstances where you need to do raw SQL queries, and I wrote my raw SQL queries, and I was scared of that. So when you do, just make sure that you don't get the usual review. You get 5 reviews from 5 different people, and then you do it over again, maybe. I mean, I'm exaggerating. But really, if you do write raw SQL queries, make sure that SQL injection is not an issue. And I mean, the not only prepared statements, but the frameworks, I mean, that's the next point. Don't do everything from scratch, use frameworks, because the use of frameworks, I think they are main contributor that actually SQL injections are on the drop, basically, while XSS is not. But also, if you're using frameworks, which take care that you don't introduce inadvertently maybe vulnerabilities, you still can, but they help you. And if you use those frameworks, well, also make sure to update them. Because there's no use in using the framework and then everything's nice and then you don't update it for 3 years. Especially if you use a framework, maybe a library, I mean, it gets tedious at some point, but usually they have some announced lists, maybe even a security announced list. Go on there, make sure whenever they announce something to check, are you affected? If you're not affected, or if you're affected, update immediately if you can. If you're not affected, still update next week, probably, hopefully. But, I mean, you could now wonder, didn't I tell you there isn't 100%? Yes. All of that is hard to do, and we can't do all of that all the time. We could try to, but there will always be circumstances where we miss an update or whatever. So the point is, try to do it, and if you make exceptions from this rule, just need to know what you're doing to make sure that somebody is involved to look at that and that some process is in place to alleviate whatever you are currently doing and shouldn't be doing. And for all of that, the key takeaway in my experience is, well, nag your higher-ups about secure coding workshops and a software development lifecycle, a secure software development lifecycle that takes security serious from the start. If you don't have that, and this gets back to the opening keynote, if you don't have that because you're in a desert environment, well, you are flawed. You can still try to do all those other things, but you'll burn out doing them. Literally burn out in the desert sun. So nag everyone about that. If you want to have proper secure software, you have to need time to do it properly. So these are my takeaways. I'll also leave that quote for you to look up later. It's by WordFriends, from his WordFriends report. It's just about automatic updates. Automatic updates are a great thing, especially if you don't have a lot of security measures in place that make sure that something still must not need to be updated, but you can patch it partially or whatever. So use automatic updates if you can, and if you don't want to use them, make sure you have other mechanisms in place. Most of the time, people have arguments about automatic updates where things might break and they don't have measures in place. At some point, it might break much more badly if you don't do that. Here are just a few references if you want to know more about the topic. Tanya Janke has a nice YouTube channel, also a great book, Alice and Bob Learn Application Security. And Sonny Moisset has an open source software security handbook. I mean, these are free, the links here are freely accessible. And also 2 articles about these specific vulnerabilities I mentioned. especially for women interested in security, there is, beginning of September, a workshop of mine where you can actually hack web applications at the Deduct Women's IT Studies. So that's it. We still have, I can't believe it, we still have 5 minutes for Q&A.